everyone, we're going to identify and graph the polar equation r equals 4 minus 2 cosine of theta. The first thing we're going to do, this is for identification, this is a Limacon without an inner loop, and I will show you that form in just a minute. But first what we want to do is test for symmetry by checking these three conditions, because we're going to have to graph this. For the first condition, we're going to see if it's symmetric with respect to the polar axis, i.e. the x-axis, by substituting in my theta with negative theta. Well, basically, we're just testing if it's even or odd function. This is an even function, so we can just change that to positive. Cosine is even. Since it equals back to my original equation, that means we pass condition 1, so our graph is going to be symmetric with respect to the polar axis. All right, let's test condition 2. Condition 2, we want to check and see if it's symmetric with respect to the line theta equals pi divided by 2, which is the y-axis. So basically what you do is you take your r equals 4 minus 2 cosine and substitute theta with pi minus theta. Now if we get the same equation back, the test passes, and if we don't, it fails. So this is your sum and difference formula, has this form here. So let's expand that. This equals 4 minus 2 times cosine of pi cosine of theta plus sine of pi times sine of theta. All right. Sine of pi is 0, so this is just going to end up being 0. Cosine of pi is negative 1. So we get 4r equals 4. Negative times a negative is positive. So you get plus 2 cosine of theta. This does not equal 4 minus 2 cosine of theta. So condition 2 fails. That means it's not symmetric to the line. Right now we only have it symmetric to the x-axis, not the y-axis. All right, and the last test is it symmetric to the pole? This is the easiest test, and you just substitute your r with negative r. And it doesn't equal, so this test fails. The only time the origin test will pass is if your r squared is positive, if it's squared. And that's what the Limacon thing here. So basically, this is a Limacon without an inner loop. It's without the inner loop because my a is 4. This has this cosine form here. And my b is 2. And 4 is greater than 2. For it to be with the inner loop, then this number would have to be bigger than this number. So it has this, it almost looks like the cardioid, but it's more of an apple shape, or a pear, not a pear, peach or apple shape. So let's go ahead and graph it. Now that we did our test for symmetry, and it's with respect to the polar axis, we're going to assign our values of theta from 0 to pi. So we're going to write down a table of values for theta. Start at 0. You go pi divided by 6, pi divided by 3, pi divided by 2, 2 pi divided by 3, 5 pi divided by 6, and pi. And then evaluate it with 4 minus 2 cosine of theta. This is your r. So when theta is 0, my r is 2. When it's pi divided by 6, we're going to have 4 minus square root of 3, which is approximately 2.3. At pi divided by 3, my r is 3. pi divided by 2, my r is 4. At 2 pi divided by 3, my r is 5. And at 5 pi divided by 6, we have 4 plus square root of 3, which is approximately 5.7. And at pi, we're at 6. So let's plot some of these points. At 0, our angle is 0. We're going out 2. 1, 2. So there's that point. At pi divided by 6, we go out close to 2, just a little further out. At pi divided by 3, we're going out 3. So 1, 2, 3. At pi divided by 2, we're going out 4. And then at 2 pi divided by 3, we're going out. There it is, 5. And 5 pi divided by 6, we're going out close to 6. And at pi, we're at 6. So 1, 2, 3, 4, 5, 6. So there's our shape. We're going out this way and around. Now we know it's symmetric to our polar axis here. So we can just swing it back around and I'm working backwards. So here we're going to go to 5.7. So very close in. At the 4 pi divided by 3, we're going out to 5. At 3 pi divided by 2, we're going out 4. 2, 3, 4. And you just use symmetry to help you graph this. 1, 2, 3. And at the 6, it's 5.7. So that's, let's see, 2.3. Close to 2. And then we're back to 2. So go back around and just swing back around. And this is how you graph it. And that's it. Thank you. Have a nice day. Bye-bye.